Here is another situation where you want to distinguish between a differentiation rule and what a differentiation, what the derivative is, the addition rule. Now, I'm sure you're very familiar with this rule from high school, and in fact, it's a rule so simple that probably you have taken it for granted. The rule says if you have a function which is made up of a sum of two terms, each of which is a function, well, the derivative of that sum is given by the sum of the derivatives of the first and the second one. This looks intuitively clear, but why should it be true? In fact, it turns out that the similar rule for products does not work. Okay, so we need to prove it. So how do we do that? Once again, we go back to the definition. Here is what the limit definition of a derivative looks like in the case where our function is a sum of two terms. So we have the first of all, both of those functions evaluated x plus h and added up, and then we subtract both of those two functions. Now we're going to play a little trick. What we're going to do is we're going to look at those two terms there, and we're going to put them together. We're basically going to rearrange the numerator of that fraction, and then we're going to take the second two terms, the ones involving g, and we're going to put those two together. Now at this point, our limit looks like a fraction consisting of two pieces, so we're going to split that up. So we're going to split that up into the limit as h approaches 0 of the pieces containing f only, and the limit approaching 0 of the pieces containing g only. Well, at this point, we have basically separated the f and the g, and when we look at the first piece, we recognize that that is just the formula that defines the derivative of f, so that's just f prime. And the same way, the second piece is just the formula that defines the derivative of g, the limit definition formula. So that's just g prime. Very simple proof, but we need to go through it. We cannot simply assume that just because the operation is simple, it extends to the derivatives. So, as an exercise for you, prove the subtraction rule. Is it true that if we take the derivative of a difference between two functions, that's simply given by the difference of the derivatives? Again, follow the same procedure, and you will get that the answer is yes. Now, here is one rule, one differentiation rule that causes a great deal of confusion, and that is the power rule. The power rule is the rule that we use when we're dealing with a power function. So a power function, of course, looks like x to the power n, and the rule says, well, if you're dealing with a function of the form x to the power n, its derivative is going to be given by n, this time looking as a coefficient, times x to the power of the same n as before, but minus 1. Well, this rule is seen by many students as being actually the definition of derivative, and nothing could be further from the truth. In fact, the power rule is the only one rule that we will not be able to prove fully. Its full proof is very, very complicated. We're going to be able to prove it in just a few individual cases. In fact, it's easy to prove that it works for small positive integers. It's not too difficult to prove that it works for any positive integer, even for a million, in the exponent, of course. But when it comes to other cases, well, they create problems. We're going to see some of them later, and I can tell you right away that the most general case we will not be able to see. We're going to stop here now, actually, and refer later for the product and quotient rules.